Assalamualaikum warahmatullahi wabarakatuh and hi. Today we'll present our chosen topic for assessment 2, which is group project for mathematical logic and proving technique subject MAT222. We have choose topic 2.4 logical implication as our topic. First of all, let me introduce myself. I am Nur Adalah Nadia binti Cik Norshan. Here is my group members, which is Nur Syamimi Atira binti Khairul Suhairi, Nur Ashikim binti Mahadi, Nur Jasnita Junira binti Luqman Al-Hakim, and Nur Syafiqah binti Othman.
So next is a definition of logical implication. We consider the implication like the slide shows. Hypothesis, P1, P2, and other P with a constant N. P here means premises, and we also have the conclusion at the end. So the note here, N is the positive integer, and the statement P1, P2, and P with a constant N are called premises. So for logical implication, we have two definitions, which is if A and B are two logical expressions, and if A implies B is tautology, which means all the conclusions are true, we say that A logically implies with B, written as A implies B with the symbol arrow to the right. And for definition 2 is a valid argument whose conclusion is true whenever the premises are true. So one way to show that an argument is valid is to show that P1, P2, and another P with a constant N is a tautology, which means all the conclusions are true. So the symbol we use for logical implication is we also have two, implies and not implies. For implies, we have arrow with the equal, and for not implies, we have equal. We have arrow with the equal, but we use the symbol slash or not. So now I will explain the example so that you guys can understand the definition of logical implication easily. So look at the example 1. It asks us to prove that the following expression logically implies using truth table. So for A, P implies Q and negation Q implies negation P. First, we need to divide the equation into two parts, A and B. From the slide, as you can see that I did divide the equation into A parts and B parts. So the solution is, I'm pretty sure that you guys already learned how to find the true value from all of the terms in the equation, like I did in the table, which are P, Q, negation P, negation Q, P implies Q, P implies Q, and negation Q, and the last one is P implies Q and negation Q implies negation P. So from the table, you guys can see the complete table, right? So what I try to tell here is you try to see the very right side of the table is the conclusion of the table. So the true value of the conclusion are all true. So the conclusion that we can make here is, since P implies Q implies negation Q implies negation P is tautology, which means the conclusion are all true. Therefore, this equation are logically implies.
Now I will show how to solve question 4b from past year question June 2019. The question is, construct a truth table to determine whether X and not Y logically implies not X or not Y. Firstly, we need to have the equation first from the question, which is X and not Y implies to not X or not Y. So firstly, we need to construct a table that have 4 rows, exclude the first one, because we only have 2 unknown. So for column X, we need to put 2 true and 2 false. For Y, we need to reduce the number of true, and it should be true false, true false. So for not X, it should be totally opposite from column X. So when X is true, then not X is false. So it should be false, false, true, true. Same goes to not Y. It will be false, true, false, true. So for the next column, X and not Y, as the statement is AND, so when there is one false, it will be false. So true and false will be false, true and true will be true, false and false will be false, false and true will be false. So for the next column, not X or not Y, as the statement are OR, so if there is one true, then the statement is true. So false or false will be false, false or true will be true, true or false will be true, and true or true will be true. So for the last column, X and not Y implies to not X or not Y. For implies, if the first statement is true and the second statement is false, then the equation of implies is false. So for F implies F will be true, true implies true will be true, false implies true will be true, and false implies true will be true. So seeing X and not Y implies to not X or not Y is tautology. Therefore, X and not Y logically implies to not X or not Y.
The question is, P disjunction Q by conditional negation of Q implies not P disjunction of not Q. Construct the truth table. First, we know that P true, true, false, false, and Q true, false, true, false, and not P is false, false, true, true, and not Q is false, true, false, true, and P disjunction Q is true, 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 false, and P disjunction of Q by conditional of not Q is false, true, false, false. Next, a negation of P disjunction of negation of Q is false, true, 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 and P disjunction of Q by a conditional negation of Q implies negation of P disjunction of negation Q is true, 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 true. The final answer is tautology.
Next question is, construct a truth table to determine whether negation P or Q bracket and P and Q bracket logically implies P and Q. Firstly, we need to draw a truth table. So first of all, we need to find the proposition in the question. So the proposition in the question P and Q. So number of rows we will get 4 because 2 quasi root of 2. We will get 4. So first row we need to write down P, second Q, third negation of P. But fourth, we don't need to write down negation of Q because in the question they didn't mention it. So next row we just put in the bracket first, such as negation P or Q and P and Q. So in the row P, we need to write down true, true, false, false.
and Q, we need to write down true first, true first. For the negation of P, we need to write down before true, like false, false, true, true. And for negation P or Q, so here we will look at it at negation P. So in the negation of P, we get false, and Q, we get true. So when the symbol of O, we can get false or false, false. You get it? Else we get true. So here, true, negation of false, and Q is true. So here is true, and so negation P for number 2, we get false 2, but Q we got false, and false or false we will get false. So negation P, number 3, we get true. True, with true we will get true. True or first we will get true. Then next, P and Q. So for P and Q, we will look at row P and Q. For symbol of N, if true and true, we will get true. Other than that, we will get false. So here, number 1, we will get true. Number 2, we get false. Third, false, and 4, false. So next question is P and Q in the bracket. So also same in the P and Q, we will get true, false, false, false. Same with negation P or Q and P and Q, we get the same, true, first, first, first. But we need to check it carefully because we don't need, we scare, it will false sometimes, right? So for the hypothesis, we get implies P and Q, we get all true. So when it all true, it means tautology. Since negation P or Q bracket and P and Q implies is tautology, therefore negation P or Q and P and Q implies to P and Q.
In conclusion, the statement is logically implies when all the true value are true, or it is called tautology. So the statement of P implies Q is logically implies when all the true value of P implies Q is true by using truth table. However, if one of the true value is false, the statement is not logically implies.